Good morning, everybody. We want to welcome you to this webinar. This is the third in the series for this year for our CMAHC webinar series, and we're pretty excited for this topic. Today, we're going to discuss understanding artificial swimming lagoons and these very unique novel facilities. And again, we want to thank everyone for taking time out of your day to be here. I'd like to introduce our speakers today. First, we have Commander Joe Laco with CDC. Commander Laco is one of the principals who deals with the MAHC and all-around expert in public health. And he is leading our Artificial Swimming Lagoons Ad Hoc Committee to develop guidance for CDC and also change requests for the 5th edition. Our other speakers today include Jeff Littlejohn, who's a consultant for Crystal Lagoons and another member of the ad hoc committee. And we also have Ken Smith, who's president and CEO of H2O Lagoons. Yep, Jeff, we can hear you. If you'll just kind of mute for a second. So Ken Smith is president and CEO of H2O Lagoon Solutions, and again, another expert in the field of these swimming lagoons. The reason why we wanted to have this webinar today is quite simply to get some education out there, right? These are novel facilities. There's not that many around the country, but they are growing in popularity and scope. And as we discussed this thing called swimming lagoons, we realized we need some education because these are different creatures. So that's the impetus for this webinar today. Just a few housekeeping notes. Please keep your lines on mute. We will not have a open verbal Q&A today. Instead, if you have any questions, please put those in the chat box for the webinar, and then we'll go through at the end of the presentation and address these questions in order until our time is up. We're going to take about 45 minutes, 40 to 45 minutes for the actual presentation on lagoons, and then spend the last 15 to 20 in Q&A. So with that being said, Jeff, I'm going to turn it over to you, sir.
All right. Thank you, Dewey. Can you hear me now?
Yep, loud and clear.
Okay, very good. I was having a little sound issue at the beginning. Appreciate the introduction and the opportunity, and looking forward to going through this with everybody today. So this is an exciting topic for me because I think, as Dewey mentioned, I work for Crystal Lagoons and have been working for them since they entered the U.S. market here in Florida back in 2014 or 2015. And just getting, as a former regulator myself, getting your head wrapped around the regulation of a facility like this can be a daunting task. And so we're going to talk about some of the approaches to regulation, and then some of the approaches that the ad hoc committee has been working towards. So first, I think everybody loves an origin story, and I particularly love this one. I'm a Floridian, born and raised, and I was at the River Country. Probably not the first year they were opened. I would have been 5 years old back then, but I was there probably the next year. And this was marketed really as the first water theme park in the world. And this particular facility was pretty rudimentary. It was attached to, basically dug out of the shoreline of a natural lake here in Florida called Bay Lake inside the Walt Disney World complex. And at that time, they used large pumps and a high turnover rate into the lagoon there, and they used filtration to achieve the water quality requirements set by the Florida Department of Health in an operating permit. Many years later, for a number of reasons, the facility was permanently closed, but it set a benchmark for this type of theme park, and in Florida and around the world, and we've seen a lot of proliferation. This, of course, isn't the only type of artificial swimming lagoon, and there are lots of other examples around the United States. There are many examples that even have been around, prior to River Country, that were simply impounded streams or modified lakes or impounded portions of springs. Some of these artificial swimming lagoons have some form of disinfection. Others have some monthly testing. or bacteria, for example. But there are actually many that have no regulatory requirements at all. And one of the questions I think, again, as regulators, with a low public acceptance of the risk of waterborne diseases being a major factor, I'm not sure we'll see the proliferation of many more of these types of swimming lagoons. Instead, I think what we're seeing is an abundance of new types of artificial lagoons, which is really exciting to the industry, and particularly with many new types of uses that are unique to the industry, like surfing. A lot of these new artificial swimming lagoons share, or some artificial lagoons share common features like a liner. I believe they're all being disinfected in some way, shape, or form, and have some form of filtration. But again, with kind of the new types of technology emerging, and just because of their sheer size, these types of artificial lagoons often don't have the conventional turnover requirements or conventional approaches to disinfection or filtration, or even the requirement for disinfection residuals that we're used to in a public swimming pool. And water quality is, of course, a primary concern with regulators. So what else do we have out there? And so I'm very excited about this example of an artificial lagoon, because this was created by the company that I work for, Crystal Lagoons. So these lagoons are the product of a lot of research and development into alternative approaches to achieving extremely high water quality, extremely high clarity, because the approach by this company was to create something that really does look like an artificial but natural looking tropical lagoon. And so one of the benefits of this technology is the ability to create truly enormous artificial tropical lagoons, which adds to that illusion of being, surrounded by palm trees, and provides the opportunity to introduce a wide variety of water-based activities besides just swimming. And so this aesthetic-focused approach to the technology is certainly changing the market in aquatic venues, and is necessitating some new approaches to their regulation. So two approaches to the regulation of these types of facilities as they entered the US market are what I would like to call lake-like or pool-like. And in Florida, where I live, the regulators here took a lake-like approach to their regulation. In other words, they recognize that these are not conventional swimming pools. They recognize that regulations didn't exist that there were no regulations in place to regulate them. And so they looked to another set of regulations in Florida to regulate natural water bodies like lakes and springs and beaches. And there were bacteriological standards and testing and things that could be applied. And that was the conventional approach, or the original approach to their regulation in Florida. By contrast, in other states, Texas, for example, or Nevada, there were provisions to regulate a facility like this in a variance process to the conventional swimming pool regulations. So those jurisdictions took a pool-like approach to regulation, but having to grant a lot of variances to accommodate the differences in how they actually are constructed and function. So why is a new regulatory approach even needed? Why not just regulate them as a swimming pool? Well, clearly they are different in some obvious ways. These are incredibly large volumes of water. They enjoy really incredible dilution rates compared to a conventional pool. In other words, with such large volumes, you can't ever achieve the bathing load or the bather density in the water volume that would add all of those the risks and the things that come with people in swimming pools, the things we need to disinfect. And then, of course, there's really remarkably different construction methods and different systems to maintain these facilities. So the water quality treatment technology itself is something that's very unconventional compared to a regular swimming pool. And then you start to add on to that, layering lots of different uses that may include swimming, of course, but also has other forms of uses in recreation and water sports. All of these combine to really a need to take another look at the regulation of these facilities, and that's happened in a lot of states. I think what we're seeing is an emerging trend that I think I like to call a hybrid approach to regulating these facilities. In other words, to look at the different regions of a very large artificial body of water, an artificial swimming lagoon, and treat them differently in the regulations. And so there are parts of the lagoon where you're going to primarily or entirely use those large areas for water sports, sailing, paddleboarding, kayaking, etc. Those are areas where the bathing load is zero or close to zero. You're not going to have immersion taking place. You might have an incidental injury if you fall off your paddleboard. But they really lend themselves well to a lake-like approach to regulation, where you do need to establish and maintain a minimum set of bacteriological standards. Clarity and other things may be important for safety. You're certainly going to incorporate some safety provisions to ensure people are safe out there, but that can be very much driven by an activity or a user-based approach to safety. By contrast, other parts of an artificial swimming lagoon can have areas that are focused on swimming, that are separated from the water sports area into what we call designated swimming areas. And within those designated swimming areas, the bathing load is much higher. And of course, we want to be able to provide that water quality, the same set of water quality standards that you would enjoy in a public swimming pool, that the public really expects and demands, and is consistent with what regulators are used to. Certainly some provisions of construction are going to be different, and I'll talk about a few of those, for example, but then safety becomes much more standardized, something much closer to what you would expect in a conventional swimming pool. So given the magnitude of these types of facilities and some of the variety of features and activities, it's not surprising that regulators initially struggle to fit this facility into existing codes and rules. So whether the issue is water quality or construction methods or plumbing and filtration or safety, the regulations that were in place when Crystal Lagoons entered the US market just weren't really sufficient to deal with this. So thankfully, CMAHC recognized this and formed a new ad hoc committee to tackle this type of aquatic facility. And so the CMAHC convened an artificial swimming lagoon ad hoc committee in 2019. It's got a diverse membership with CDC represented, plus regulators from 4 states, within which there are active or planned crystal lagoon facilities, or artificial lagoon facilities. And then there were industry reps, including myself, representing the company. Our objective with the ad hoc committee was to really get our heads around the applicability of the Model Aquatic Health Code, look for what type of scope of regulation would really be appropriate for these types of facilities, and ultimately develop a guidance document that could turn into code at some point in the future. But our approach to the review of these facilities was really to focus on the performance base, focus on not how water quality standards are achieved, but make sure that water quality standards are appropriate and safe and protective, and then establish some performance-based set of regulations for these types of facilities. So I've got really a graphic here to start to explain some of the mechanics of the regulation that our ad hoc committee came up with and is recommending. So this graphic was used by the committee to illustrate a number of major concepts in one of these large facilities. And this is a pretty typical facility. It's actually the first facility in the United States. It's north of Tampa in west central Florida. And this is about typical in terms of size. This facility is about 8 acres. And of course, just a massive facility with a lot of different types of uses and users. So wanting to take advantage of and use existing MAHC terminology whenever possible, we started to try to describe a facility like this in those terms. And so the artificial swimming lagoon itself, consisting of the deck areas and the restrooms, all of those are subject to regulation under the MAHC, and we believe that's really appropriate. And so that's the we describe that entire facility, aquatic facility, in the MAHC that way. So an artificial swimming lagoon, including restroom and deck areas, can be thought of as a very large aquatic facility. The lagoon itself can be thought of as an aquatic venue. And to distinguish a lagoon from a conventional public swimming pool, we decided to recommend a minimum size threshold. So 20,000 square feet is about a half an acre. Again, this is 16 times larger than that minimum size, but this is a way to distinguish the venue itself from the facility that contains the decks and everything else around it. And then within these aquatic venues, you may have areas that are designated for swimming, and we define these and call these designated swimming areas, or DSA. And there are other aquatic features that may be contained within a venue of this size. For example, the climbable structure area, or some other type of aquatic feature, again, which have regulations in the MAHC that define how what kind of safety provisions should be incorporated in them, and really fit well in the overall structure of the regulation. So we didn't want to do really any damage to how those regulations currently work, or try to redefine them in a new set of regulations to regulate these. So once you're in a designated swimming area, and on this graphic, these are the dark blue kind of oval or wobbly shapes. These are going to be areas that have beach entries. These are going to be areas that are physically separated from the rest of the uses of the lagoon. So those non-swimming water sports uses are going to be marked off, or these designated swimming areas are going to be marked off so there's no conflict between users. And then within these areas, that's also a visual cue for lifeguards to make sure you keep the swimmers inside these areas. And these are areas, and this is really important, where the water quality requirements that are consistent with a public swimming pool are going to be achieved and must be achieved. And so there are design and construction performance requirements in the guidelines that have been established to help achieve that. And I'll get in more detail about how some of those features. And this is really very much a schematic of how a facility like this works. This is not proprietary to Crystal Lagoons, but is again a general schematic of how facilities like this can be made functional, so that these designated swimming areas can achieve those higher water quality standards, and the water sports area may not. So in this graphic, you'll see that the source water for the returns that are oriented into the designated swimming areas actually comes from the main lagoon, from that water sports area, or that non-designated swimming area. And in this particular graphic, that source water is routed to a sump from which pumps will pressurize that flow and move it through a filtration and disinfection system to achieve the proper water quality standards, to re-inject that water back into a designated swimming area, so that designated swimming area is maintained at that higher water quality level, where disinfection residuals are assured or maintained, and where, due to the distribution and number of nozzles, return nozzles, that flow of water is constantly moving from those shallower designated swimming areas into the body of the lagoon, again, from which that water is then returned back through the system over and over again. And with this type of approach, a facility designer is able to achieve, again, that higher water quality, maintain a residual concentration of disinfection chemicals, and achieve a renewal rate. So some assurance that you can not turn over the entire volume of the lagoon, but turn over the area within a designated swimming area within a time frame that's consistent with a conventional swimming pool. Having the water returned to a sump through a sump system where pumps are pressurizing the rest of it for the return means you're not having to worry about moving massive volumes of water out of an area that could where a bather or a swimmer or somebody could come in contact with that return is something that's very important for safety. And with my company, with Crystal Lagoons, there has been an awful lot of science and engineering and technology that goes into the design and the both the location and the orientation of these nozzles to ensure that this positive hydraulic gradient can be achieved. And there's computational fluid dynamic modeling done with every one of these facilities. But this is a tracer dye testing study that was done as a visual demonstration of the effectiveness of this technology. And in this particular scenario, this artificial swimming lagoon has a designated swimming area that functions along the way I just described. And it also has a physically isolated conventional swimming pool structure that's attached to the side of the lagoon. So this was a great opportunity to also showcase how the same amount of dye may be dispersed or distributed or picked up by the filtration system and the return system, or in the case of the artificial swimming lagoon, simply pushed offshore by that hydraulic gradient. So this is the same quantity of dye released at the same time at these two locations in the photograph at the top left. 5 minutes later, you can start to see the dye expanding. And in the case of the swimming lagoon, you can also start to see it being pushed out of the designated swimming area by that slug flow that's happening from the return from the nozzles. In 15 minutes, most of the dye has already been moved, or about half of the dye has already been moved out of the designated swimming area. And by 25 or 30 minutes, in this particular study, this particular lagoon, the vast majority of the dye has been successfully removed from the designated swimming area, all replaced with filtered, disinfected, new water. And again, over longer and longer periods of time, that designated swimming area, that volume of water in the designated swimming area has been completely replaced with disinfected and filtered water. So, kind of culminating in the work of the ad hoc committee over the last couple of years, just wanted to recap a couple of main points, and then I can stop it here, Dewey and Joe, for questions and comments. But the approach for the ad hoc committee is really to follow this hybrid approach. We're going to separate the areas of the lagoon by use and focus on an approach to regulation that's appropriate for that use. So a designated swimming area is going to have a higher water quality standard, functionally equivalent to a public swimming pool, with minimum disinfection residuals, minimum renewal rates, and so on and so forth. By contrast, those non-swimming areas or those water sports areas have a different set of requirements appropriate for their use and the number of users. There are relatively minimal prescriptive criteria. Again, our approach to the regulation of this type of facility was not to specify a particular design or particular type of material, because this is an emerging type of technology, and the technology that Crystal Lagoons uses may be different from the technology that some other company may use in this type of market. And removing those prescriptive criteria allows us to focus on a performance-based approach to ensure that bather safety and protection from water quality perspective. So within designated swimming areas, again, there's a minimum disinfection residual requirement, minimum clarity requirements, cryptosporidium removal standard that's consistent with and appropriate compared to a conventional public swimming pool, substitutes renewal rate concept in lieu of a turnover rate, recognizing that the entire volume of the artificial swimming lagoon is not being turned over, but the renewal rate or the volume within the designated swimming area is being turned over. And how that is accomplished is through that positive hydraulic gradient that has to be demonstrated by the designer when a design is submitted to the AHJ. Also a visible separation so that you can distinguish those designated swimming areas from the water sports areas for the lifeguards and for the users, so they don't have conflicts. Then by contrast, once you move out into the body of the lagoon where you're maybe paddleboarding or sailing or kayaking, dropping down to something closer to a lake-like approach to regulation, where water quality is still important. There are water quality requirements, minimum water quality requirements for natural water bodies that establish minimum criteria for bacteria. We added those to our recommendations, plus clarity standards. These are artificial water bodies, not natural water bodies, and the ability for safety reasons to see to the bottom is something that was important. So we did add clarity standards to the recommendations, but no, and this is really important, no requirement to maintain a minimum disinfection residual throughout the entire body of the lagoon, just recognizing that there's little or no bather load or contact with bathers. Regarding safety, all the current requirements for a conventional swimming pool are adhered to within those designated swimming areas. But then again, once you move outside of the designated swimming areas, a much different approach to safety, user-based and activity-based rather than swimming pool-based. And with that, I think there's undoubtedly going to be some questions, and I'm happy to stop talking and take a breath, and I'll leave it here, or I can back through to another slide if there are any questions from the crowd.
Right, thank you, Jeff. We're actually going to turn it over to Joe Laco, Commander Laco, to fill in some things from the CDC perspective. As a reminder, and there are some questions coming in, please feel free to post your questions in the chat, and we'll handle those one at a time with our panelists today. Joe, it's all yours.
Thanks, Dewey, and thanks, Jeff, for providing some clarity on these unique venues. As was mentioned earlier, artificial swimming lagoons have emerged as a new and innovative way to enjoy recreational water activities. And there are some of these already present in the United States, with even more planned for future construction. States like Florida, Texas, North Carolina have already begun to preliminarily address these unique sites in their health codes. During the last changes request cycle for CDC's Model Aquatic Health Code, there was a proposal to add a section for artificial swimming lagoons. It was not clearly understood and was ultimately rejected. So in the absence of national public health guidance, the CMAHC created an ad hoc committee to address the needs of public health practitioners responsible for responding to health and safety and the issues specific to artificial swimming lagoons. Together with CDC, the ad hoc committee is developing, as Jeff mentioned, interim guidance to serve as an adjunct that's being prepared for inclusion into a future version of CDC's Model Aquatic Health Code. The guidance document is currently under review and will ultimately be made available on CDC's Healthy Swimming website, and hopefully be included in the next change request cycle for the MAHC, and we'll see that hopefully in a future version of the MAHC. The interim guidance document will address minimum standards for artificial swimming lagoons by establishing minimum design and operating requirements to ensure proper filtration, disinfection, maintenance of the water, and reduce the risk of drowning and injuries for bathers and patrons. The biggest need of all of this process here is to help better folks understand how these types of venues work and can operate safely. When I first saw these ideas years ago, I immediately did not buy in. I couldn't wrap my brain around how they could possibly work. And it took having conversations with folks like Jeff and Ken also on the line here to answer some questions, and to have these visualizations through webinars like this, through presentations like this, with some of the pictures and schematics that were provided to really help me grasp. Yeah, that one right there. I love that schematic. That's really the one that shows how the water flows and the big overall concept about the designated swimming area's water. So hopefully today's presentation and speaking with our experts provided much needed insight to artificial swimming lagoons. And Dewey, I'll turn it back over to you to start fielding some of these questions. And we got Ken and Jeff on the line. I think that'll be able to get most of these answered for you.
Great. Thank you, Joe. Thank you, Jeff. I'd like to reintroduce Ken Smith. Again, he's the president and CEO of H2O Lagoon Solutions and one of the U.S. technical experts, actually probably one of the global experts on artificial swimming lagoons. He'll be joining us for the Q&A period. Before we get into the posted questions, I'm going to toss out just kind of a discussion question to Jeff, Joe, and Ken. And it's impromptu, right? So I apologize if I'm popping something on you, right? But my big question is for attendees today, as we have worked through and as y'all have worked through this thing called swimming lagoons, right? From a MAHC perspective, from a future CDC guidance perspective, what has been some of the biggest challenges that we've had to overcome or had to address in this process from your perspective?
I'll answer
That question first. I think the biggest challenge, we saw it very clearly when we submitted the change request for the last MAHC update cycle. It got to the technical review committee for the change request to include artificial swimming lagoon guidance, and people just couldn't wrap their brains around it. There just seemed to be a lack of the concepts of how they work, how they could work safely. So I think the biggest challenge is helping folks better understand how they work, the concepts of the water flow, and how it does incorporate the pretty standard safety swimming concepts about filtration, disinfection, lifeguarding and such with the DSAs. So I think the education aspect of it is one of the biggest challenges for artificial swimming lagoons.
I would echo Joe's comments exactly. I think when regulators first started to hear about the type of facility, there was a natural reaction to wanting to separate the swimming area from the non-swimming area with a physical barrier. You shouldn't have a swimming pool that's open to a lake. How do you keep those two volumes of water separate if your intention is to have a separate set of standards for the quality or the type of disinfection, residual present, et cetera, et cetera. And I'm an engineer. A lot of regulators are very technical people. They can understand the technology, but understanding it and getting comfortable with it, are maybe a big divide. And so it just took a lot of education, a lot of discussion, having a first facility in the ground in the United States and being able to point to it and take regulators in Florida. At least we were able to accomplish a lot of tours with our Florida swimming pool industry and a lot of regulators around Florida. And as people got more comfortable with the technology being able to achieve these stated objectives, I think that helped close the gap between seeing it and believing it.
This is Ken Smith with H2. Thank you guys for attending and the questions that are coming through. And let me reiterate the same thing that Joe and John have expressed. I have a different perspective from the educational part where they had the regulatory exposure and the governmental exposures from a national and a state level. My exposure was more at the local and city and county level, and education on that perspective, because it was the ones that were right in their backyards, was so key. And as they mentioned, education is the biggest thing. What's so different about this? Why? How can this be okay in comparison to 50 some odd years of other codes and regulations that's protected the public from anything that could harm them? And obviously some of the growing pains from coming from an international perspective to United States here, I saw a lot of eyes opened, as Joe mentioned, with just explaining how it works and actually having the boots on the ground and seeing these things in person and understanding that it's not just a cut and paste or a Photoshop, but actually something scientific and something that the hydraulics and the fluids and the particulars from a bacterial monitoring standpoint have been successful. So currently there are 8 of these larger venues that are under a certain product, a company that Jeff has mentioned, but they're probably going to be more out there. But I've seen it evolve just over the last since 2017 to a more superior engineering feat from what we can provide here in the United States, and from an agreement with the regulatory process too. And it's just been amazing. And I think this is definitely going to be something that is going to be in everybody's neighborhood over the next 5 years, from the East Coast all the way over to the West Coast.
Yeah, and you know, just echoing, the education issue has been one of the biggest factors we've had to deal with. We saw this early on with adoption efforts for the 4th edition that ultimately failed. You know, just kind of as an aside, you know, as we look at swimming lagoons and novel venues, I think we're kind of at a point technology-wise, design-wise, where we're going to start seeing more and more interesting construction, more and more novel facilities, right? Whether it's artificial swimming lagoons, whether it's surf venues, whether it's, you know, other novel wave pools. And, you know, the biggest issue for the future is just getting everyone out of the square pool mindset, right? And I think as we see more and more facilities that are new and new designs pop up, artificial swimming lagoons will be paving the way and breaking those barriers for new ways of thought and new ways of consideration as we move forward. So thank you guys. So just as a reminder, we're taking questions in the chat. We're going to start the Q&A phase. So the first question, and thank you, Joe, for pulling this slide up, is how many of the photos in the first few slides are actual photos of existing facilities, and are they in the US?
So these are real photos, and the top 2 and the bottom left corner are in the US in Florida. The bottom right, I believe, is overseas. But I've not put up any fake photos. These are all real. This is the United States. This is in Pasco County. These 3 are the 3, the top and the bottom left are in Florida.
Great, excellent. I think we've already answered this, but just addressing for clarity, is the designated swimming area, DSA, separated from the lagoon by a wall or a rope and floats?
A rope and floats.
Yeah, rope and floats, correct.
Mm-hmm.
Great, thank you. For a DSA, is the water quality supposed to be measured by manual collection of samples? Is there a requirement that the sample be collected in a certain place?
So I can answer that real quick. There is manual collection of those, and there's also a lot of these facilities set up for on-site permanent collection of permanent monitoring of that. But from a bacterial standpoint, those are manually collected strategically and in agreement with the local body, whether it be a county or state regulation of how far they have to be separated. And typically, as one of the questions said, I think that might, I'm not sure if it's this one or next one, but they are separated in the DSAs to be, you know, strategically sampled. So.
Right. Just a follow-up question on the permanent monitoring. Is this using traditional, you know, monitoring ORP, PPM sensors, or is it using some other mechanism?
There's a variety. A lot of them have, you know, For example, to meet swimming pool regulations, you have to monitor pH. You have your ORP, which is your sanitization factor, that's monitored. And that's typically the larger scope of it. And that can be done with plenty of technology that's out there.
Great, excellent, thank you. The last follow-up for this question is, and guys, y'all see this as well, perhaps at the point in the DSA that is farthest from an inlet should be considered. Is there any light you can be shed on how the water collection is done to ensure adequate sampling throughout the DSA?
I mean, there obviously you don't want to, when it comes to manually sampling, you have to be sure that you're doing it accurately and so forth. And from areas that might not see, you got, again, getting out of that square box. This isn't an area that is perfectly like a swimming pool, but it replicates it from a hydraulic standpoint. So typically, as shown as a dye test, you'll be able to get a renewal of water in there during the presence of swimmers and so forth. And so areas that are typically in like 90-degree areas or other areas that are just not as susceptible to, some of those, as the question asked, it does get a turnover. And even for that large body of water, it's not going to be anything that's going to be stagnant or so forth. Does that help at all?
Yeah, I think so. Here's an interesting question. Would there be any value in adding cyanuric acid in the DSA, or would the dilution negate the value of adding that cyanuric acid?
That's a great question. On some of these bodies of water, as you can see in the picture, I know the one on the left is about 16 million gallons, and the one above that, that's the one in Texas. That one's closer to 28 million gallons. You can imagine the cyanuric acid levels to be able to do that in that large body of water would be, I don't know how cost effective compared to just a standard liquid sodium chlorine, but because of the turnover there, it would probably just get pushed out into there. So there would be a possible use, but it just constantly is moving water through that. So it'll just get put into a diluted state. But it is being used some minimally in some perspective from some of the places that I'm aware of and I've seen operate. And it's just a cost effectiveness, whether you put more chlorine in or you use some of the cyanuric.
I would imagine, just kind of spitballing here, I'd imagine that, the dilution needs for cyanuric acid, once it hits certain levels, for this kind of water are maybe prohibitive for the use of it. But that's a really interesting question and interesting problem to address specifically for each individual DSA and lagoon rather. So that's a good question. That's a very good question. Next question, how is this ad hoc committee addressing the growing desire for non-chemical disinfection for DSAs through natural biological processes? Joe, do you want to address that one from a CDC standpoint?
Yeah, currently the Model Aquatic Health Code, we are really more focused on the filtration and chemical disinfection, particularly with halogen use of chloride and bromine. So right now we do not encourage use of natural biologic processes for swimming pools or designated swimming areas in the artificial swimming lagoons.
Great, thank you. Next question is, how do you stop algae and plant growth in the non-DSAs?
Ken, I see you're pausing. I'm happy to
Oh,
take
no.
a crack at
Yeah,
this. and
you go
can
ahead.
fill in.
You can go ahead, or I can just, let me jump in real
Sure.
quick, because it's such a large body of water, right, guys? This isn't an indoor facility or have anything protected from the outside. So obviously, organic matter is going to be introduced, especially with construction going around, plant life, trees, and so forth. But as Jeff has explained, some of the technology has been used to be able to not, so these things aren't like stagnant pools or stagnant ponds. They actually have some movement in there, but there is a proprietary combination of water treatment that's being done to avoid stuff like that. And without getting into anything from an IP standpoint, you take a look at some of these lagoons and you can see they range from anywhere from 8 to 10 to 12 feet. And then some of them are even coming in at certain places at 15 feet, depending on what's going on there. So that's a pretty large and deep body of water. The idea behind this is to not treat the entire water column, but to actually take the material that is in the water and take it somewhere where it can be treated, which is on the bottom. So you imagine that you could take one of these big venues, you drop in any type of water treatment facility, suspended solids, organics, and so forth, and you use whatever it needs for a flock or a surfactant. You combine it, drop it to the bottom, and then it's removed from there. So the intent in that is that one of these venues getting to another point, you just can't plug it in and play and not expect it to be able to operate itself without daily oversight. So when you take that concept and perception of how to operate and maintain these, it is an everyday, every moment type of situation that is constantly being monitored and treated. So you're removing a lot of that stuff from those water columns and just taking it and mechanically separating it from that water, giving it that crystal clear, type of perception that you see right now.
Great, thank you. I'm going to address the next question. The next question is, are surfing areas and surf parks considered pool or lake in the hybrid model? I'm actually going to punt this question to the future. CMAHC is working with CDC with an ad hoc committee to develop a guidance document similar to swimming lagoons for surf venues. That process is a little bit more complex due to the engineering of surf venues. And we hope to have that completed and more information end of this year, first quarter or two of next year. Hopefully sooner than that. The committee is working diligently, but trying to give us a little bit of a buffer there on getting that information out. So we will have in first or second quarter of 23 a similar webinar here for surf venues where we can address the hybrid model and filtration, et cetera, for surf venues. So Mr. Miller, please be patient and we'll address that in the very near future. And just to be honest, the engineering between artificial swimming lagoons and surf venues are as different as a combustion engine to a Tesla. So it's not really a fair question to throw on these guys that deal primarily with lagoons. So again, we'll look to the future for that answer for that question. So the next question for the panel, in a facility with no DSA, is there a guideline or target being set for renewal or turnover rate? I'll toss it over to Jeff and Ken.
Speaking for this, for my particular company, we don't have any expectation of having an artificial swimming lagoon or a crystal lagoon that doesn't have a swimming area. So these are built for swimming. the balance or the leftover of the lagoon that's outside of the DSAs are used for all those other uses. And then the size is also driven by the need to create that visual aesthetic that this is that this is like a tropical lagoon, with the palm trees and everything else around it. So swimming is really central to it, and as is the size of it, which is going to accommodate all those non-swimming areas.
Great, thank you. I'm going to combine the next two questions because they're very similar. When we talk about the DSAs and the non-DSAs, the lake-like areas, right? What activities are allowed and not allowed in both the DSA and the lake-like area?
So the DSA, you can think about it as a swimming pool, and the vast majority of them are zero depth entry or beach entry swimming pools, functionally and in terms of what kind of uses you would expect. Outside of those areas, and I'll add this too, I think within those areas, changing or shaping the bottom and creating something like an island, that's something that's very popular, and I think you'll see a lot of those. But still, all of that is all incorporated, can be incorporated within a designated swimming area, and used by bathers in conventional swimming pool types setting. Outside of those areas, really, it's up to the imagination of the end user, and the kinds of uses that we see most often. Climables are pretty popular. Certainly all of the non-internal combustion engine type of vessels, from kayaks to stand-up paddleboards to even small surf or sailboats, are all very common and compatible with both the technology and other similar uses. So on this screen, you see a few different things going on. You can see really 3 designated swimming areas. The one with the island in the middle, the one where the bottom of the slide is coming out, and then over kind of in the bottom right corner. In the middle of that, in a deeper area, is a climbable structure, and it is the only way to access the climbable structure is by going through that vendor, where you get your safety lecture, and you get sized and put on a life jacket, and then depending on whether you can swim or not, you're assisted out to the depending on your level of comfort and age and whatnot, you are either you swim out to the climbable or broad out. And then there you can see there are we may not be able to tell, but there are lifeguards out there as well. They're provided by the vendor that operates that climbable. So that's really consistent with where you might see climables in other lakes or at beaches. It's a popular type of activity, but the bathing load is, it's regulated by the number of users allowed on the climbable at any one time, and so it's an extremely low bathing load. And while there is certainly immersion, if you fall off or jump off a climbable, you're going in the lagoon. It's no more immersion than you might experience at a lake or a spring or a beach where these are pretty common, and where the water quality standards are really more lake-like than pool-like.
Great, thank you. We've got about 6 more minutes left on the webinar. We do have a series of questions we want to try to get to. Next question is a very important one, what is being done to prevent the sump area from being a breeding ground for infilarii?
So real quick, just to address that question, that you're talking about the area that is used for that one diagram that Jeff put up with the sump area going back through the filtration and back through the DSA. Is that what you're talking about? Yeah, this slide right here.
Yeah, correct.
So there isn't a a stagnant area, I would say. A lot of this, again, this diagram here is just showing a general hypothesis of how this could be, the water could be removed, whether it being gravity or hydraulically lifted out of there. But as to any area, it's typically not used like your basic swim pool, where the lowest level of your reservoir is where you draw like a main drain, you might want to say. So these things aren't set up like for that, for the main drains, because that's not the primary idea, is to turn all the water over. So in that perspective, there is constantly water being like brushed. The liners are brushed, the walls are brushed, the pits that some of the recirculation nozzles that are in the DSAs are monitored and cleaned. So it's not like there's one area, even in some of the monitoring stations that are located, like we talked about in DSAs, those are physically being cleaned and sanitized. So there's not like one spot that you could start a growth of algae or stagnant water and taken from there.
And
So
Ken, please correct me if I'm incorrect, but you know, the sump area and really the whole lagoon isn't sand lined. It's a liner system.
That's
so there's
correct.
no sand for Naeglerii to embed itself in to be a future hazard, correct?
On the ones that I operate, yes, that's correct. There is no sand introduction to where you'd have to aerate that with a sanitation agent. It's all a cleanable surface, whether it be a vinyl liner or an epoxy painted surface on the wall or the zero entry beach and so forth.
Great, thank you. Last couple of questions. What considerations are made for wildlife entering the lagoon?
Well, I got some stories being in the Tampa area and in Texas. Mostly Florida though. So, you know, during construction of these things, you know, obviously there's safety barriers that are put up for keeping a safe environment from people, right? But once in a while, honestly, what wildlife will come through, birds migrate to Florida. We'll find a large bird population in the wintertime because they migrate down here. And also some of the other wildlife, there I've seen an otter, I've seen an alligator, I've seen a crab, I've seen fish, but they've been moved quickly. Honestly, it's just such a daily presence there. So if something does need to be removed, it's done appropriately with whatever is there. But these swimming lagoons currently are in communities or public areas where you won't see that wildlife right then and there. Like I'm just saying, for the aggressive ones, the alligators, you don't see that. I have seen a baby one in there, but I actually think that a bird dropped it in. Fish, I've seen birds drop fish in because they're getting it from adjacent ponds. But the birds themselves, they use on a lot of these, just so the birds aren't sitting on the zero entries or any areas. They'll use a couple different methods. They'll use some calls from predator calls, and they'll also use sometimes some fishing wire in some areas, fishing line, to stop the birds from coming down like you see at some restaurants. And so it's not as big as a problem. Sometimes you'll see ducks come landing in there, but most of the time it's because there's so many people around there. It's dealt with every once in a while and so forth. So
last two questions, right? So we'll go like a minute or two over. So if we can kind of keep the answers a little bit on the brief side. Is a traditional pool barrier or fence required, or is it open access like many lakes in populated areas?
I'll take this one, and I can be brief. There is a pool enclosure or something substantially equivalent to a pool enclosure required, at least as we contemplated the regulations, and it is maintained at the aquatic facility level. So the main barrier entry on this particular drawing would be that green boundary. So once you enter into that enclosed area where there's controlled access, where you might have to pay or you be a member or be a resident to get through, that access is controlled at the aquatic facility boundary. Once you're inside the boundary, there is no separate or second enclosure area, although there was some discussion about if there were a separate aquatic venue like a child's or a toddler pool area, that might have its own self-contained enclosure area, but that would be a separate venue inside the facility.
Right, thank you. Last question for today. What does a typical flow rate look for these lagoons inside the DSA and without?
It really depends on just how you calculate a flow rate for a swimming pool. Not all of the designated swimming areas are the same size, so they are appropriately engineered to be able to address that. I've seen some flow rates at 1,000 gallons a minute for some, and some at 250, and then one that's in between. So it varies depending on the length, the depth, and the size of the area.
Great, thank you. I want to extend a huge thank you to our panelists, Jeff Littlejohn, Ken Smith, and Commander Joe Laco for being here today and helping CMAHC educate the industry at large and public health on these novel facilities. And also want to publicly thank them and the rest of our ad hoc committee members for the work they're doing in helping create guidance with CDC and also for future proposed additions to the MAC. So thank you much for today and for all efforts as we move forward in the future. I want to thank everyone for attending today. And I would like to take a moment to promote our next webinar, which will be in December. The specific date will be announced relatively shortly within the next 2 months. But we're really excited about that one as well, as we have representatives from NSF here to discuss NSF 50, NSF 61, and all things pool performance standards from NSF. So please look for that, and we hope that you'll join us for that webinar as well. Want to thank everyone for attending today. We hope you have a great rest of the day. Remember that CMAHC, your membership is important to us to have your voice heard, and we are driven by your expertise. So if you are not a member, please consider joining CMAHC today. You can find more information at cmahc.org. Thank you, everyone. This concludes the webinar, and we'll talk with you soon.